Hey everyone, this is Joe at the National Weather Service in Billings. As we head into summer, I wanted to share a final look at this past winter and offer some explanations as to why we saw as much snow as we did. We finished the season with 103.5 inches of snow at Billings, breaking the old record of 98.7 inches in the 96-97 winter. Here's a map of snowfall totals and their departures from normal across the region. The values in red are records, and as you can see, record snowfall occurred at Billings and McLeod. Also note that the greatest amounts fell in an area near Billings and along the north slopes of the mountains, and this is because of a large number of north wind or upslope snow events during this past winter. You have to lift air to generate precipitation, which is what happens when wind blows up the side of a mountain, and this is why areas such as McLeod, Red Lodge, and Story, Wyoming received so much snowfall and almost always receive more than other lower elevation locations. Also, thanks to the many co-op observers around the area for their daily snowfall reports, maps such as this wouldn't be possible without them. Let's take a closer look at Billings snowfall divided by month. By far, our snowiest months were the midwinter months, December, January, and February, when we received an amazing total of 79.1 inches. This might come as a surprise, but the total of all other months combined was actually a few inches below normal. So when we talk about the snowy year we had, we really have to focus on midwinter. We'll get to why this happened in just a minute. Taking a quick look at temperatures, December and February were colder than normal, but January was actually a warmer than normal month. Overall, the November through March period was colder than normal by a few degrees and ranked as the 26th coldest on record. We had 3 distinct cold snaps, one in early December, another in early February, and the last in late February to early March. Billings reached 20 degrees below zero on 3 separate occasions, and prior to this past winter, we had not seen a temperature that cold since 1997. But overall, our average temperature was not even close to a record, and in fact, this past winter was not as cold as the 2010 and 11 winter. So why was it so snowy from December through February? It'd be easy to say it just happened, but I wanted to at least show you the type of weather pattern we experienced, in a general sense. So let's take a look at some average weather charts for the 3-month period. Keep in mind that averaging these over a 3-month period will wash out any individual storms. The top left map here shows wind flow at mid-levels of the atmosphere, and the bottom right shows departure from normal of the height of this level. Basically, these show that we had a weather pattern dominated by an active northwest flow. See the white arrows on top, with a deeper than normal low pressure system anchored to our east. See the purple colors on the bottom right. This flow favored a large number of upslope snow events on the north side of the mountains in our region. Now here is a different level of the atmosphere, closer to the ground, with the shading on the top map this time representing temperatures, and the bottom showing their difference from normal. The bottom right map shows a large area of well below normal temperatures across the northern plains and central Canada, including eastern Montana. The combination of an active northwest flow aloft and frequent cold surges into eastern Montana gave us our snowy conditions not only for the foothills and mountains, but other locations such as Billings, Columbus, Big Timber, etc. Remember that locations further east were drier this past winter. You could say that locations such as Miles City and Baker were east of the favored storm track. Okay, so why did the weather pattern set up as it did? Well, that's a tough one to answer, but here are a few probable factors. First, sea surface temperatures on the top left show an area of warmer than normal ocean in the North Pacific. As a result of this, areas such as Alaska and eastern Siberia experienced a very mild winter. This warmer air displaced the colder air, which would normally be stuck in the northern latitudes, allowing for frequent cold surges into the northern United States. Second, on the top right, is a graph of polar sea ice. Much lower than normal ice cover was observed through this past winter. Less ice cover actually allows for more frequent warm spells in the Arctic, which again allows for cold air to push further south. Now, because of the lower than normal ice cover, this air isn't as cold as it could be otherwise, so even though it was a colder than normal winter for us, it wasn't even close to record cold. Third, on the bottom right, is a snapshot of snow cover in early February. Southern Canada had a large and persistent snow cover throughout this past winter, and this also makes it easier for colder air to surge into Montana and the northern plains of the U.S. Without the snow cover to our north, this past winter would have been warmer and in all likelihood not as snowy for us. Last, on the bottom left, although this might not be the answer people are looking for, luck definitely plays a role in our weather. Weather patterns tend to lock into certain positions over periods of time, and in the case of midwinter, the weather pattern definitely favored snow in our region. All of these factors likely contributed to us seeing our first 100-inch season, and to be honest, Billings has almost certainly seen 100 inches in the past, just not since records began in 1934. You could say we were due. Finally, what about next winter? Well, winters are certainly independent of each other, so the snowiness of this past winter has no bearing whatsoever on next year. A few things to think about, though. There is a developing El Niño in the tropical Pacific Ocean. This could mean a slight hedge toward warmer and drier conditions for us next winter, but that is not always the case during an El Niño. There is still below normal sea ice in the Arctic Ocean, so that again will be a factor. And let's not forget the chaos embedded within our weather patterns. Remember, due to our location on the east side of the Rocky Mountains, our winters are characterized by alternating periods of warm and dry and cool and wet weather, along with periods of wind, of course. So as always, it's best to be prepared for a little of everything. Thanks for listening, and have a good summer, everyone.